Good morning, CSU. This is Tony Feudale, and today I'm going to be talking to you about cross-site scripting. So, cross-site scripting, it's a common vulnerability with some pretty large consequences. It's an extremely common exploit, and in a survey, Symantec said that it accounted for about 84% of vulnerabilities they detected. HackerOne has identified it as the most common exploit in 2017, and it does not just affect small players, but it also affects big important companies like Google, Facebook, and even the Obama administration. So this has got a lot of consequences. So what is it exactly? So it is a form of code injection. So basically what happens is an evildoer or perpetrator takes advantage of a user's browser to execute some malicious JavaScript. So basically some JavaScript is delivered to the user from a vulnerable website. So here's a simple example. A server-side script here, it's displaying a user message on a website. So it comes in, here's some HTML, and it prints out a message stored in a database. So how this can be taken advantage of. So a malicious user submits a script which contains some malicious code. So instead of writing in so for their comment, they'll write in something like script malicious code / script. Now, when this is displayed by a user's browser, it gets recognized by the browser's JavaScript and executed, which allows the attacker to succeed in their attack. So why does this matter? So executing some rogue JavaScript may seem harmless, but it can have big consequences. So, for instance, cookies can be stolen, and these could contain sensitive information. The attacker could also make use of the code to send similar attacks to other users, and the contents of the page itself can be modified, which could make it easier to do things like phishing or to run a keylogger to gather sensitive information on the user's computer, and any of these things can directly harm the user or others. So there's three types: persistent, reflected, and document object model based. So in persistent, the first example that we showed was persistent. Some sort of string is injected into the website and persists there in some sort of database, and that from the database is distributed to the user, right? So the next example is reflected. So in a reflected attack, some malicious text comes from the victim's request itself. So basically what happens is a user is tricked into sending a request to a website that actually contains malicious text. So the website then returns a response, that response itself contains that malicious text which was originally sent by the user. So then, at that point, the victim's browser executes the code and does whatever nefarious thing the attacker wanted it to do. So typically in these kind of attacks, they're oftentimes spear phishing. So specific users are targeted using some social engineering, or also there are cases where there's sort of a large wide net phishing type attack where perhaps somebody posts a malicious link on a social media site and tries to get that widely distributed. So the third type is document object model, and there's a key difference between this one and the other two we have reviewed, and that is that in this particular type, the flaw does not rest on the server, but actually in the client code. So an attacker crafts some sort of nefarious link which a victim requests from a server. The server responds, but that response from the server does not actually contain any malicious code. Instead, the victim's browser runs the code that was returned by the server, and the running of that code actually causes the malicious code in the original link to be inserted into the page on the client side. So at that point, that code gets executed. So the key difference here is that previously we needed a vulnerability in the server in order for these attacks to succeed. Now we just need a vulnerability on the client side. So it's just a different avenue of attack. So there's a lot of ways this can happen. What can we do to defend against it? So there's two means of defense, and they have some shared properties. So the shared properties are context. So depending on where in the website user input is being put in, you have to treat it differently, right? There's also inbound and outbound. So we can defend the website either coming in or going out, and maybe we should do both. And then finally, there's also client server. So the data or the input or the website should be secured both on the server end and also on the client end. So you have to look at both ends of the equation. So means of defense. So the first one is encoding. So basically, one way we can avoid cross-site scripting attacks is via proper encoding. So in our original, for example, the caret symbols, the presence of those in the code was what allowed this cross-site script to attack to succeed. So if we instead treated all caret symbols as a different Unicode representation, and we store them, perhaps something like and_lt, or this, right? That could actually prevent the code from being run, because instead of seeing those caret symbols, the browser would only see these other Unicode symbols, which wouldn't get recognized as JavaScript and hence executed. So downsides, clever attackers can still find ways around this encoding, and it's ineffective if you want a legitimate user to actually be able to modify some part of a page's code. So it's limiting relevant XKCD here. Validation, so you can also validate input. You can either do that via blacklisting, so you can forbid certain patterns. That's hard to get right, and it becomes obsolete over time as patterns can change, or you can only do whitelisting and only allow certain patterns, which is simpler and generally doesn't run out of, doesn't become obsolete over time as you only allow certain patterns. And finally, when you have invalid input, you can either reject it outright, or you can try and sanitize it. So you can either just throw it all out, or you can try and remove some dangerous parts of the code, which can be hard to get right, but gives more flexibility to user input and is less restrictive. And here's the summary. Okay, so now part 2, the security tool. I chose the Avira antivirus. All right, so what is it? Avira is a humble antivirus. It's just commercial antivirus software, so it detects, prevents, and removes malware on your average user's computer. So Avira is a German-based company. It's based out of Tettnang, Germany. It was the company itself was founded in 2006, but the Avira antivirus has actually been in development since 1986, and it's got a very large customer base with about 100 million users, so it's a big player. So how does it work? So a library of known threats is maintained. So during a scan, code on a computer is compared to a threat library, and anything that matches an existing threat in that library is quarantined and then escalated to the user for removal. There's also a heuristic engine which monitors for suspicious patterns of behavior, and code which exhibits these patterns are flagged, they are quarantined, and then they are also escalated for removal by the user. Now, those generally are just, they exhibit suspicious patterns, but they don't actually match a known threat in the library. So then that suspicious code is sent to Avira with user permission, of course, for evaluation, and then it can be possibly added to the threat library. Avira also monitors not just code on the computer, but email, browser activity, and cookies if you so choose. So now I'm going to demo how that all works for you. Okay, so I've opened up Avira here, and as you can see, it's got a couple of options, different devices you can protect. So here I'm just concerned about the antivirus, so I'm going to click open here, and that will take us to the scanning protection. So there are different things you can do. You can see there's some activity lists as well as a quarantine. We're just interested in a scan, so I'm going to come over here. I'm going to click full scan and then start the scan, and that'll get things scanning. So this is going to take some time, so we'll just let this go, and I'll turn this back on when it's finished. Okay, and I'm back. Scan successfully finished, and we can see that there was a log of this, so a scan was completed, including the number of directories that were scanned and the number of detections. So if we come over here to quarantine, we can see that one of these files has been moved to quarantine, this guy right here. And if we click this little information tab, it'll take us to the Avira website, where it'll tell us a little bit about the particular piece of malware that was detected. In this case, it was a piece of adware. So adware is basically just software that displays ads. They're typically just sort of an annoyance, but this was flagged and then moved to quarantine. And we can actually go through and we can select this, and we can either restore it, we could rescan it, to double check that it is in fact a piece of adware, or we can delete it. So I'm just going to delete this. And you'll notice that that one was marked in red, whereas this one is marked in yellow because it is simply a suspicious file. We could probably safely restore this one. But that is the gist of how the Avira antivirus works. Thank you very much.